Swayam Prabha. Digital India. Educated India.
Yeah, welcome back. So, we will continue from our discussion of three-phase rotating MMF wave. That is a very fundamental discussion that we did in the last class. So, let me recap first what we were discussing. So, if I have a phase winding, suppose it is carrying current I A, then the peak MMF that it will create is N I A, and this will be distributed in space as N I A cos of theta. I am not going to draw the diagram again, but you can imagine that thing from your memory lane, or it is okay. Why be so oops. Right. So, for example, we said that this is where the distributed A phase winding is there, and it is exactly distributing it sinusoidally is tough, but we can come to a good approximation of this. It is having n turns here, and that distribution. So, if this is carrying a current of say like this, will create this side I am putting dot, this side I am putting cross. So, this will create a flux in this particular direction. Of course, it will there is a iron core, there is a the armature winding is on stator, but the armature winding is on stator, but I am making again a mistake, maybe. So, 1 minute, just sorry. So, let me do this, duplicate this, cut it short and put it here. Yeah. So, what I mean to say is this is where my air gap is, right. These are usually iron structure. This is the rotor on which we will be putting a cage winding, as I had discussed in the last class, and this is the stator. This is axis, this is sometimes called D axis also. It is aligned with the A, this is the A phase winding. It is having n number of turns, and as I said, the spread should be 60 degrees on this side and 60 degrees on this side. So, that spread will be 120 degrees, then you will get for the B phase another 120 degrees spread, and then for the C phase another 120 degree spread. So, altogether you will get a 360 degree spread. And so, even though you would see that the waveform is a stepped waveform like this, spread over only this much of 120 degree, then it goes down, then it again steps up, again goes down, and so on. So, this we have done many times, but I keep repeating it because these are concepts which are very fundamental and are not that intuitive, and once we come to equivalent circuit, we usually tend to forget them altogether, but actually it is the blood. If the blood is not flowing in your body, there is no life in the body, right. Similarly, the magnetic field is not rotating in the air cap, and if you have not understood the mechanics of that, then really that equivalent circuit of the machine becomes, knowledge of the equivalent circuit of the machine becomes only a superficial knowledge, and not really, you do not understand your body itself. Just like it is very true, I mean doctors understand our body, we do not understand our body. That is why we have to go to doctor every time we have a health problem. But here you are the doctor for this machine, right. In some sense you will be the doctor for this electric machine. So you have to understand its anatomy, its physiology, its physics, everything you have to understand it, because you have to probably devise new machines in future tomorrow, and they keep coming up also, now fans earlier used to be single phase machines, now they are BLDC machines, brushless DC machines. So it change is essentially the change towards betterment. We really do not know whether things become better or not, but because we built so many thermal generators, and now we are having what do we have out of it? We are having global warming from it. So whenever we did it, we thought we did it for betterment, but today we know that it has done some betterment. GDP has improved. Electricity plays a very important role in improving the GDP of the nation, and so on and so forth. But as the planet has been harmed, and when the planet has been harmed, it is not just humans which are harmed, but all other living beings are also harmed by us. So what I am trying to say is, but now we are trying to work on it, we are trying to improve upon it. So this change is something that is something philosophically, something which is very, very fundamental. It is almost a constant, you can say. And so now the generators are changing. You have got PV or solar generation, wind generation. Now wind generation uses induction motors basically, and this permanent magnet synchronous machines. So again, it's human thought will improve upon what it has done earlier. Human thought will not every now and then come up with something new. It does come. I am not saying at all that it does not come. That is why you have Nobel Prizes and things like that going on. But usually that same thought is refined, gradually improved, models, this, that, variations, side effects are controlled, like just like in medicines, you have side effects and trials, and then you control the side effects. Something similar keeps happening here. If you want to contribute at a fundamental level, one thing is very sure, that you should understand the fundamentals of the subject clearly, and one way of appreciating it is by going through, revisiting it. I am not saying repetition. Repetition is recitation again and again. What I am saying is, we have to revisit the concepts again and again and see what they are implying to it, and dwell upon it from different perspectives, and let the mind soak them, gradually it will soak those concepts and settle down. We teachers very much benefit out of it, because when we teach a subject again and again, mindfully putting our heart into it, and so on and so forth, if we do not do it mechanically, we also get more and more insights into the subject, and that we try to pass on to you and the pillars of the future. So here that stepped waveform, periodic stepped waveform, which is in that 360 degrees, 720 degrees, another 360 degrees you add to it, and it creates a periodic waveform in space, which is f plus 2 this is the MMF wave f plus 2 pi n. If you do, it is again same as f of theta. So, the MMF waveform is periodic in space. This is my definition of periodicity, that the number of revolutions that I keep doing, I will get the I will come back to the same waveform. And then I say, as I had said earlier, based upon Fourier analysis, we can extract a fundamental, because it is a zero mean waveform. So, there is no DC component. Harmonics, we have discussed in our previous class, can be controlled to a lot of extent. So, therefore, as a first approximation, the MMF waveform NIA, which if all the turns was concentrated here, would have looked like a stepped waveform like this. It also has a fundamental, no doubt, but harmonic contents are much more. Fundamental plus harmonics are is what determines it. Then the ignoring harmonics becomes a bad approximation. Approximation is always okay, but the question really that you have to ask is it a good approximation or is it a bad approximation? If it is a good approximation, it simplifies analysis and does not impact the quality of the results. If it is a bad approximation, it may still simplify the analysis, but the outcome or the results or the insights that you get are really not up to mark. So, therefore, by distributing this winding, we saw that this becomes a good approximation of MMF waveform. This is now a very good approximation of the MMF waveform in the space. If the current is constant, then really this T function need not come at all. But you know that IA is actually given by, I mean, taking this as a reference and cosine wave as a reference and choosing the T equal to 0 point appropriately so as to match with the peak. I can write now FA theta comma T as NIM cos of theta cos of omega t. And then if you recall, we had said that in Y the next winding is going to be some 60 degrees here and it is going to be somewhere here, and then I will have the last one of it sitting here. So, if it is clear that if there is a current coming out here and current going on off here, and if I rotate a right handed screw, the screw is moving in the forward direction. So, therefore, this is the A phase winding axis, and similarly then the B phase axis, the B phase winding axis, this is the B phase, this is the C phase, this is the A phase. So, B phase axis will be again the dots on this side, cross on this side, and then it will create a winding axis is this will be A, this will be B, and this will be due to the C phase, this one and this one. So, the dots will be somewhere here and the crosses will be somewhere here. So, the dots advanced by 120 degree, then advanced another by 120 degree. So, because the axis is shifted by I am sorry, this is, I mean, this is the direction of theta is in this case is like this, you know. So, because I am taking this omega I am trying to translate it. Usually we draw it like, we want to draw it like this usually, but right now just mapping it exactly to this geometrical shape, this geometrical shape and placement, understanding that this is going to be my B phase axis, which will then therefore be, let me not keep this figure, it confuses us. So whatever happens in the B phase is NIB cos of theta minus 2 pi by 3, because when you have traversed 2 pi by 3 angle, then you will hit the axis of the B phase, then you will hit the axis of the B phase corresponding to this. So you have to travel 120 degrees in the anti-clockwise direction, and this therefore, this there can be, when it is their windings are carrying balanced sinusoidal currents. So, then this will be omega 2 minus 3 pi by 3 cos of theta minus 2 pi by 3, and then if you had FC of t, then it will turn out to be NIM, or I will write it as NIC cos of now theta minus 4 pi by 3, and this will be NIM cos of omega t minus 4 pi by 3 into cos of theta minus 4 pi by 3, and then when we sum these 3 together, which we did it using trigonometry last time. So, if I look at the f net of theta comma t, which is f a of theta comma t plus f b of theta comma t plus f c of theta comma t, then this is going to be equal to 3 by 2 NIM cos of theta minus omega t. So, what do I get here? I have basically got that if a observer is rotating at a speed omega or omega s, the rotor should be rotating, if I have connected a 3-phase supply, then the supply frequency is 2 pi f, which is 2 pi into 50 hertz. So, it should be rotating at 3000 rpm, and then if I increase the number of poles as we discussed earlier, then I can mechanical radians per second, I can reduce the synchronous speed. But for if we look at it as a 2-pole machine, or alternately in terms of electrical radiance discussion in terms of it, then if I am if the observer in the air gap is rotating at a speed omega, which is the speed of the, which is the frequency of the AC supply, then you would see, you would suppose you decided to place yourself at theta equal to 0, then at t equal to 0 you will be seeing the peak, and if the observer is, and in space this is distributed, because t equal to 0 I have fixed here, but cos of theta will give me a space distribution like this, the way I have shown it here. So, this is my t equal to 0, time is fixed, but it is sinusoidally distributed in space like this. Now, at say 2 pi, at t by 3 seconds, at t by 3 seconds, omega t, omega is 2 pi by t into capital T by 3. So, omega t will be 2 pi by 3. So, if I look at, if I take theta equal to 2 pi by 3, then at t equal to 2 pi by 3, I will get the peak sitting there, and again it is 3 by 2 NIM cos of theta minus 2 pi by 3. So, the peak happens at theta equal to 2 pi by 3, and then again its amplitude is again 3 by 2 NIM, and then it will be distributed in space as a sinusoidal thing. So, it is as if that figure went away, but it is as if this is T, this is T equal to T by 3, this is 3 by 2 NIM. So, it is as if this one has rotated at a speed omega in the forward direction. This is what has happened, it has rotated in the forward direction. So, what do you see? You see a rotating MMF wave which in space is distributed as sinusoidally, but is moving at a constant speed omega. This is the thing. So, if the observer is also sitting on that wave and rotating sitting on the wave, which means he is also carrying a rotation at the same speed omega, wherever he is sitting, whatever MMF, that value that he is seeing at that time, suppose he is at theta naught at t equal to 0, then he will see 3 by 2 NIM cos theta m naught cos theta naught. He will continue to see the same MMF, because he is rotating with the same speed as the wave speed. So, he will not see any difference in the MMF. But if he fixes his location in space, say some odd number 2.93 degrees, whatever it is, suppose he chooses some odd number 2.93 degrees. Now, this number gets fixed, t keeps varying. So, it is amplitude of 3 by 2 NIM, but a sinusoidal variation in time. So, now a stationary observer anywhere sees a MMF which is sinusoidally varying in time, and a rotating observer at the synchronous speed sees it as rotating, sees it as rotating MMF wave at a speed of omega. Then he sees basically a standstill picture, as if nothing is happening, because he has caught up with the speed of it. But if the observer is rotating at omega m, actual speed is this is rotating at omega s, the AC supply frequency, if it is omega s, then as I had said last time, this is defined as the slip. It is a the slip is a it is a per unit value, it does not have any unit, no unit, and this says how much he is slipped back. That is why that S notation for slip is used. Machine will usually slip back from the synchronous speed when you put some load on its rotor, the induction machine's rotor, when you put that cage rotor that I described earlier class, when you put up some load there, then it will slip back, and therefore, this is called as slip. And when he has slipped by a speed of omega slip, so omega m is omega s into 1 minus s, then what is going to happen is he or she will see rotating MMF at a speed which is omega s minus omega m. Suppose he is rotating at say 50 hertz. So, 100 pi, the synchronous speed is, suppose he is rotating at 40 hertz, 40 revolutions per second, 40 cycles per second, and the machine is rotating, the rotating MMF wave is rotating at 50 hertz, because our supply connected is of 50 hertz. So, it is rotating it at therefore, this can also be written by cancelling out the 2 pi factor. This can also be written as Fm Fs minus Fm by Fs. So, he is so the machine's air gap rotating MMF wave is rotating at 50 hertz, his speed is only 40 hertz. So, what will happen? relative speed of the MMF wave with respect to observer sitting stationary on rotor. So, or stationary on rotor means he is rotating at the speed of the rotor, then will be 10 hertz, which is nothing but s times of, but what is omega s minus omega m? S times of omega of s. So he will see that, he will see the observer. The observer could be a winding, it need not be a person. The observer could be just a winding, for example, a phase winding on that rotor. Then that a phase winding on the rotor is going to see a frequency of a rotating MMF wave, that means a rotating B wave running at a speed of s times of omega fs. So, if the rate of change of frequency, which is sinusoidal, is happening at a frequency of s of fs, then what would be the EMF which is induced in that winding? The frequency of the, we will be getting into this more details, not necessarily today, but frequency of the induced EMF will be SFS. And what is going to happen is, this induced EMF, now suppose I have short circuited the winding. I described you in the last class that basic cage rotor construction is like having 3 phase similar windings as we have on the stator, but with different number of turns sitting on the rotor, and then just we are short circuiting all of them in the basic structure of, in the basic induction machine. So, there is really nothing to be done there. And then if that is the case, there is, of course, every winding has a resistance and an inductance, every winding has a resistance and the inductance. So, it will when it sees a EMF which is at a frequency, if the EMF induced in it is a sinusoid, and we will see that in more detail in a subsequent class. But we have discussed, you know, how the mechanics of generating the sinusoidal voltage is exactly the same as what we have discussed in the elementary synchronous machine. Think of a stationary winding. Actually, I am now describing it to you only. Think of it as a stationary winding and a MMF which is cutting across at a speed of omega s. Then you will generate a sinusoidal voltage in time in the winding, due to the fact that the phi is continuously changing and phi is BA cos theta and all that. We will come more details of that, we can look into it, but we have seen that earlier. So, the induced at the rate at which the flux is changing, if the phi is given by phi m cos of omega t, in this case it will be phi m s times of omega s of t. And the induced EMF also that will be generated in the rotor winding will have a frequency of this many hertz, and this will flow through a resistance of that coil. And if at 50 hertz the reactance of the coil is say L, A phase coil is L, then at frequency at frequency of SFS, slip times of the synchronous frequency, the reactance of the coil will turn out to be this much. So, if I call this omega s L r, the rotor, R indicates this I will connect these things when I come to equivalent circuit. You are seeing a preamble of, in some sense, what is going to come. So, if I call this as the rotor resistance as XR, then this is at when rotor is stationary. Then when the rotor is rotating at speed omega m, then the reactance would be this is rotor reactance. Then when the rotor is stationary, this is what it is. Then when rotor is rotating with slip s, when the rotor is rotating with slip s, then the inductance of it will reduce, and for any AC current which is going to flow, therefore this will be the net reactance of rotor. So here now, so now the point is, in a rotating machine, see what you have seen in a transformer, there is also a primary winding, there is also a secondary winding, and there is a magnetic coupling between the two. In a sense, induction machine is also called as a generalized transformer. Now there is a primary side, it creates a MMF which is rotating in time. Now that rotating MMF wave with respect to a stationary winding on the rotor, let us say A phase winding, will again create a sinusoidal flux variation in space. So therefore there is induced EMF in it, therefore carries that induced EMF will cause a current to flow through it, and but because the rotor is not held fixed, because the rotor is not held fixed, that current so let's look at this. Let's say this is my this is okay. Now since I have okay, so let's think of it like this, that I have the magnetic field which is created due to the A phase, for example, is aligned in this direction. So at t equal to 0, the A phase or the net MMF wave is aligned along this direction, and then let us look at some turn which is let us look at some turn which is sitting here. Now if let us say that the current here is dot and the current here is cross, okay, the current here is dot and the current here is cross, then due to the induced EMF which has been produced in the coil, and then that has flown through this coil resistance and coil inductance, and induced EMF has created a current, and so that current is, whatever that current is now interacting with this B, then it will create BIL, the Lorentz force. Actually it is B cross BL cross BIL, so L cross I or something like that. So it will create, but the angle is 90 degrees. So it will create, if I rotate the right handed screw, dot is like coming up, this is right here. So from top to right hand side, if I rotate the screw, it is going to move here in this direction. So it will create a F in this direction, and similarly there will be a F created in this direction, and so there will be a rotation of the coil. So the point is, and now look at this, because this fellow is rotating, this will try to keep catching with it. The rotation is going to the rotation will be, this is rotating at omega in this direction, and this whole thing will be trying to keep catching with it. So it is a like a cat and mouse kind of a thing, the cat here is, the mouse here is the rotating MMF of the stator wave, and the cat is the rotor of your synchronous machine or the winding on this. But because these currents have because the rotor is not held stationary. So, the forces which are going to be created on the conductors of the windings in the rotor will cause it to rotate, and that rotation will be responsible for you rotating the load. For example, if it is if you have a wheel connected at the rotor is connected to the shaft of a, say, some wheel, then that wheel will rotate, and then whatever resistance that it is carrying, accordingly it means whatever there will whatever opposing torque it is producing. So, this torque into this will be the mechanical power which will be coming out of it, and the electrical power will have to be matching it according to law of conservation of energy, assuming of course that the we will have more details of this. I mean, there is a magnetic field energy, there is a mechanical work done, and this is the electrical energy. This is a more exact this is a more correct representation of this. When this dm by d omega t becomes 0, then the P electrical, if I look at this, this is what I will get. If the rate of change of net magnetic field, the rate of change of stored energy, the magnetic stored energy in the air gap is not changing, then I will get this equation, which is P E is equal to P M. Otherwise, I will not get that equation. So, the more mechanics, more things will come later on as we progress. You are in this lecture, honestly you are just seeing snippets of things that are going to come, the interesting things which are going to happen in the machine, but still we need to formalize things in a much better way. We need to formalize these things in a much better way. We will be doing it. Now, let me just take one random example. It is not a random example, I mean its positioning seems to be random, but it is, I think, appropriate at this point of time to discuss it. So, slightly moving across from my theme of induction machine. See, I mean, a machine need not be just a induction or synchronous or something. Anything that does work converts electrical energy to mechanical energy and helps us to do work that we desire is a machine. It is a machine. It could be even as simple thing as an actuator, for example, in a small control things, you have actuators to create, they are not really machines, they just actuate something, movement, closing a lever, closing this, like for example, closing a door or closing a switch, anything that kind of small action is also done by actuator, that also reads a, really speaking, a machine. So, those are specialized machine, not these general purpose workhorses that we are talking of. So, here I have, let us say, discussing now, just to to bring out the genericness of our discussion and not just restricting to the rotating machine only. Let us say that this is a I want to lift this weight which is against the gravity, or could be even against any other force also, force also. So, this force is against this I want to lift this, and for that I am going to send a current I through this coil. So, this will be connected through some DC supply or something like that. That is going to create a magnetic field in the air gap. For the time being, I am neglecting fringing and leakage and other effects as a first approximation. So, because these fields are like this is of course considered to be a ferromagnetic structure or something made up of iron, otherwise I cannot use a magnet to lift it up. Then this magnet will pull this and drive it towards this. So, let us say that B is the flux density in the air gap. So, the B is, how will you calculate B? Ni, if the air gap is L Hg, then 2 Lg, 1 Lg here, 1 Lg here, H is the ampere turns or that is going to be created in it. So, it will be Ni by 2 Lg will be H, and B is going to be mu 0 H. So, if I know what is my Lg at any given point of time in the process of lifting, then I can actually, and if the current is connected is I, so it may be a current source instead of a voltage source, and then the B will turn out to be, in the air gap will turn out to be B equal to mu 0 H, and this usually we take it as infinite. In the ideal case we take mu r to be infinity. So, therefore, there is no energy stored in this, but only the energy which gets stored in the air gap. So, that would be B square by mu naught, half of B square by mu naught joules per meter cube. Am I right? Think about it. It is not real. You can even derive this if you want to. I will leave it to, I think we have discussed this earlier. So, the Wm, so suppose now this moves by a small length dlg because of the pull, but at a 0 speed, so that I do not have to worry about the kinetic energy of the rotating of this mass which is being pulled up, that part I do not have to worry about. So, let us say that the F and this are almost balancing each other. So, then the change in the magnetic field energy, is going to be equal to half of B square by mu naught into, let us say, A is the area of cross section, times Lg. So, this is per pole. Per pole means this is one pole, this is one pole. So, dlg, I am sorry, because the volume dV that has changed is A times of dlg. So, whatever was that stored magnetic energy, so that stored magnetic energy will change by this much value, and this should be exactly equal to the work done. This should be exactly equal to the work done, which is F times of Lg. So, therefore, if I look at this FLG, this will be change in the magnetic field energy, work done will be due to the change in the magnetic field energy here and the change in the magnetic field energy here. So, therefore, I will have to do 2 times. So, I will write it as 2 times half of B square by mu naught A times dlg, and this is F times of dlg, and the work done, mechanical work done is F times of dlg. So, the whatever is the, because I am not allowing the current to change, Actually, I have shown here as a DC, but let me show this as a current source here instead. Because I am not allowing the current to change, so I am not allowing the current to change. So, um, F into this dlg will be equal to this. Only thing that has happened is magnetic field energy has changed by a small amount. dlg is close to 0. So, B has really not changed, we can ignore the change which is happening. As the magnet, as that thing gets lifted up, Lg will keep reducing. So, if I have kept the current same, then the H will increase, so the B will increase. So, it depends upon what kind of current control mechanism I have placed. Here the B will increase as I keep going up, but for a small change dlg I can take infinitesimally change in the dB can be ignored, because it will be like B plus dB whole square by 2 mu naught and then times of dV, and then when you do the linearization, taking you back to your calculus, this product of dB into dV can be ignored. So, therefore, F times of this, the change in the magnetic field energy, can be approximated or equated to change in the work done is equal to change in the magnetic field energy. So, cancel out the dlg part and you will get that F is equal to half of B square by, sorry, half is not there. This is the force which will be exerted to lift it. So, ideally if you want yeah, so this is the force to lift up. So, if the load is see, this also tells you that current control if I want to do, because I am not trying, I am trying to keep my things simple. I am not allowing this fellow to pick up velocity, even though it is moving up. I am trying to do it at like it will take ages to reach up to here. That is what I am trying to say. It will take ages to reach up to there. If I am trying to say that it will take ages to reach there, then it means that the dx by dt is as close to 0 as you can bring it, so that this half mv square business is completely avoided. Transient response and other things we can see later on, I am not talking about that, but when we are talking of this equilibrium conditions and the basics around it. So, in that case, if the load is F, the I should be controlled. So, this I now should be a controlled current source, I should be a controlled current source. So, then the I should be a controlled current source in such a way that if the opposing load torque is the load, the weight which is going to be, which has to be lifted up, is exerting a force F, which could be m times of g on planet Earth. On some another planet it could be something else, or it could be against some other mechanical resistance you are trying to lift it up. So, whatever it is, then if I want to lift it up, I should choose my current in such a way that, so how much current is required to start this process, to start the process of lifting up. This H we have seen is Ni by 2 Lg and B is mu 0 of H. So, B square by 1 by mu naught joules. So, mu naught n square I square by 4 Lg square, mu naught square by mu naught will cancel out. So, n square I square by 4 Lg square joules should be equal to F. So, from here if you know how many newtons you want to lift it up and you know what is your air gap and you know how many number of turns are there, you can calculate I, and it does not matter whether you send the current like this or send the current like this, because the force is only dependent upon I square. So, the direction of current in this particular example is not really that important. Then knowing the F, you can calculate this. Now, because of this force, the force should be incrementally infinitesimally more than this. The moment the force is infinitesimally more than this also, this thing will start moving, you know, you will not be able to pursue it. Like for example, astronomy kind of examples that you do, change is happening, but you are talking over a span of billions of years and so on and so forth, right. So, how much is the earth cooling down, for example, in a day, the core of the earth or something like that. It is a very slow process, it is over a long time interval, but that does not mean that it will not happen. That does not mean that one day the sun will not become extinct, because sun is also cooling off. But if you see the intensity of sun today and the intensity of the sun tomorrow, do you see any difference in it? You do not see any difference in it. It is not like when I was born sun was very hot and now I have become 20 years, 30 years, 50 years old and now the sun's intensity has gone. No, it will, even for generations to come, they will not perceive that the sun is cooling off. So, something similar is what we are talking of. This process of lifting it up, because we are not allowing the kinetic energy to build up here, will take infinitesimally long time, but yet over that it will get lifted up, provided this F is just this I is infinitesimally more than this value that you calculate from this equation. This will start moving up. As it starts moving up, Lg will start reducing. As the Lg will start reducing, so the I that is required is F 4 Lg square by mu naught n square. So, this current to lift it up, as the air gap starts reducing, the current to lift it up, the same force will start reducing, the current required will start reducing. See, look at it, like there is a iron log here, my magnet is somewhere here, I have to put a huge amount of current to lift it up. But if it is somewhere closer, then I do not need to put that much amount of current to lift it up, and now the gap reduces, then to lift it up I need even less current to lift it up, and that current which I require to lift it up is also inversely proportional to the number of turns. So, it is not like necessarily that I need a huge amount of current. By increasing the number of turns on the coil, I can reduce the number of amount of current that is required, but I can lift this magnet. So, this is also a very basic elementary machine, and the one basic equation that now I am closing this lecture. I will continue with our rotating MMF discussion in the next class, but the learning is that d electrical in general is equal to the work done, electrical input, change in the work done, d omega electrical, the incremental energy, electrical energy that I plug, that I push in the machine will create a small change in, will get us infinitesimally small amount of work done, which is d w mechanical, d not omega, d w electrical is equal to d w mechanical plus predominantly change in the magnetic field energy in it. So, this is what is my general governing equation for the energy balance equation that I have to that I have to work into when I discuss electrical machines. I think we will stop here for now. Thank you.